Hello friends, from our today's lecture we are going to start our new chapter of heat transfer subject, which is radiation. In our previous lectures we have learned a detailed content of the conduction mode of heat transfer. We know how the heat will transfer by the convection mode. Now we are going to study radiation mode of heat transfer in detail. So let's start with the first slide. We know there are three modes of heat transfer. First one is a conduction, second one is a convection, and third one is the radiation. Now let's take one revision for the conduction. We know in a conduction mode of heat transfer, to understand, let's take one example. If we give heat to metal rod from at this point, we know that after some time this heat will travel along the rod and the heat will reach to the end of the rod. So basically what happened here, the atom which get the heat from the outside will energize and vibrate at its own location. That highly energetic atom will give that heat or energy to adjacent atoms, and that's how atom by atom the energy, or we can say that the heat, will travel from the one end of the rod to the last end. Second, the free electrons which are traveling within the system, within the metal rod, also take heat from the higher energetic particle and give this heat to the less energetic particle. So there are two phenomena which is responsible for the conduction mode of heat transfer. First one is the lattice vibration of the molecules, and the second one is the free electrons. So let's understand this phenomena by this video. In this video we can see that we have a one metal rod, and if we apply heat at the end of this metal rod, let's see what will happen. Here we are applying heat at the end of the metal rod. Now let's see what actually happens to the atom. So here we can see that there are atoms which are vibrating at its own location. The atom which will get heat from the outside will vibrate more, and the energy which he gets from the outside, that energy gives to the adjacent less energetic particle. So this is the one phenomena which is responsible for the heat transfer. Second, here we can see there is a free electron which take heat from the high energetic particle and give that heat to the another less energetic particle or another free electrons. So this is the two phenomena which is responsible for the conduction in the solids, and majorly conduction happens in the solid within the system which have a more free electrons and atoms. The materials which do not have free electrons are the insulator. They are not a good conductor of the heat. So this is how the conduction phenomena occurs. Second is a convection. We have already discussed the convection mode of heat transfer. Convection is nothing but a conduction with a fluid in motion. This is the simple definition of convection. Convection is nothing but a conduction with a fluid in motion. Whenever there is a solid boundary with a fluid surrounding it, and if there are temperature difference, then the heat will transfer from the solid boundary to the fluid, or from the fluid to the solid boundary, by the mode which is known as the convection. Here in figure we can see that this is the hot egg, and in surrounding there is air. So what will happen here, the layer of air which is in contact with the hot egg will take heat from the hot egg, and that layer gets, the temperature of that layer become much higher as compared to other layer. And as we have here provided the external source for the flow of the air, here we have provided fan for the flow of the air. So the next layer, which is the besides of the previous layer, replace that layer which is around the hot leg. If you provide external source for the flow of the fluid which is surrounding the solid boundary, then this mode of heat transfer known as the forced convection. If there is a natural convection, it means if there is no external arrangement to flow of the fluid, and at that time whichever convection takes place is known as the natural convection or the free convection. In a free convection, here we can see that the first layer of air which is going to be in contact with the hot egg, that layer get the heat from the hot egg. The temperature of that layer becomes high as compared to other layers. So whenever there is a rise in the temperature of the layer of the air, the density of that layer becomes low as compared to other layer. So that less dense and high temperature layer is replaced by another layer. So less dense layer will move upward in this direction. From this arrow you can easily know that the less dense layer which gets the heat from the solid boundary of the hot egg will rise, and the another layer which have low temperature and high density will replace that layer. So this is two modes of convection. First is a forced convection, second is the free convection, or we can say that the natural convection. So in a conduction and convection we require medium. Conduction happens within the system, within the solid, so there must be atoms for the conduction or free electrons for the conduction mode of heat transfer. For convection there must be a flow of fluid and the solid boundary. So for the conduction and convection we require a particular medium, but the radiation, the third mode of heat transfer, which is very different from the conduction and convection. To understand in a radiation how heat transfer will take place by the radiation mode, let's take one example. Suppose here we have a very hot object which is kept in a vacuum chamber, as you can see in this figure. Suppose the initial temperature of this vacuum chamber is at room temperature. This hot object which is kept in the vacuum chamber by support of a very thin string of non-thermal conductive material. So here you can see that the temperature of this object is very high as compared to the wall of the chamber. So because of the temperature difference, there must be a heat transfer between the wall of this chamber and the hot object. But as we can see here, there is a vacuum, there is a no medium, there is a no fluid around the hot object. So the convection mode is not possible here, because for the convection mode of heat transfer we required a fluid around the solid object, but there is no air or no other fluid in this vacuum chamber, so there is no convection. Also for the conduction we required a physical contact between two systems. So we can see from this figure there is no physical contact between hot object and the wall of the vacuum chamber, so there is no conduction also takes place. But still, if we measure, after some time, if we measure temperature of this wall, there will be a rise in the temperature of the wall of the vacuum chamber. So from this experiment it is confirmed that the heat transfer must take place between the hot object and the wall of the vacuum chamber. It is not a conduction, it is not a convection, but it happens by the mode which is known as the radiations. So there must be something which is going to transfer from this hot object to the wall of the vacuum chamber, and due to that the heat is transferred from the hot object to the wall of the chamber, and this mode of heat transfer is known as the radiation. But the question is how, what is happening between these two that is responsible for the heat transfer. To understand this, first we need to understand the wave. What is wave? Because for the radiation heat transfer, the thing which is responsible for the heat transfer by the radiation is electromagnetic wave. And to understand electromagnetic wave, first we need to understand what is wave and what is electromagnetic wave. In our previous semesters we have already, and in our 11-12 standard in physics, we have already know what is wave. From this animation you can understand this is how we created a wave. This is a simple mechanical waves in which you can see that the particles are not moving in this direction, but the energy, we can say that the energy which you apply here, and this energy is going to be transported from one end to the another end. Here you can see that the energy which you provide at the one end is moving from this end to the last end, so that the energy which you have provided at this end is transferred to this end, and this is known as the energy mechanical wave. But the electromagnetic wave is very different from this mechanical wave. To understand what is electromagnetic wave and how it is generated, we need to understand this very carefully. Here we see that there is a one positive particle and there is one negative charge, positive charge and negative charge. We know that whenever there is a positive charge or negative charge, there is a electric field around the positive charge and the negative charge. So we can see the field by this which is denoted by these arrows. This arrow shows the electric field around this positive and negative charge. So whenever we apply heat to any atom or any particle, any charge, that atoms vibrate at its location. We know that whenever we apply heat to any atoms, that atoms get more energetic, more energized, and it will start vibrating, because you are giving energy to some particle, and the particle which gets the energy, which gets the heat, it's going to vibrate at its own location. So here we can see that the atom is going to vibrate at its own location. So whenever this particle, the atom which have electric field around it, and it start to vibrate, so because of the vibration, because of the changing in location of that particle, the electric field around that atom is going to change continuously, and due to change in electric field, due to change in electric flux, it's generate change in magnetic field. I repeat, due to change in electric field of particle, there is a change in a magnetic field also, and the change in electric field and magnetic field generate electromagnetic wave, which look like this. In this figure you can see that there is a change in electric field as well as magnetic field, which is responsible for the propagation of electromagnetic wave. Here there is a blue line and there is a red line, because electric field and magnetic field, the plane in which electric field is changed and the plane in which magnetic field are changed, are perpendicular to each other, and the direction of the propagation of electromagnetic wave is also perpendicular to the change in electric field and the magnetic field. Here we can see that the electric field is changed in this direction, the magnetic change in magnetic field is in this direction, and the propagation of electromagnetic field is in this direction. These three are perpendicular to each other. So this is how electromagnetic wave is generated. Now, so this is the difference between the mechanical wave and the light wave. Light wave means electromagnetic wave. In mechanical wave, there is a motion of energy from one end to the another end. In electromagnetic wave, there is a change in electric field as well as change in magnetic field, and due to the change in electric field and magnetic field, there is a propagation of electromagnetic wave in particular direction. Now let's understand what is the importance of this electromagnetic wave in radiation, how electromagnetic wave is responsible for the radiation mode of heat transfer. So this theory is given by Maxwell in 1864, that accelerated charge or accelerated charges or changing electric currents give rise to the electric and magnetic field. As we just studied, that change in, or if you give heat to any charge, any atom, it will accelerate at its own location, and that acceleration will give rise to the change in electric and magnetic field. That rapidly moving field is known as the electromagnetic wave or electromagnetic radiation. Now let's understand energy emitted, or we can say the electromagnetic wave which is emitted by the molecules contains some energy, and that electromagnetic wave transport energy just like other waves, and all electromagnetic wave travels at the speed of light in a vacuum, which is speed of light. Every wave have its own property, and electromagnetic wave are also classified also characterized as their frequency, which is denoted by mu, or wavelength lambda, because every wave has its own wavelength and frequency. The frequency of electromagnetic wave, which is denoted by mu, and the wavelength, which is denoted by lambda, and the relation between lambda and mu, the relation between frequency and wavelength, is lambda is equal to c by mu. We have already studied this equation in our 11th and 12th standard. Lambda is equal to c by mu. Lambda is the wavelength of the wave, c is the speed of light, and mu is the frequency of the wave. Now, from this equation, frequency of electromagnetic wave, we can see that frequency of electromagnetic wave depends only on the source, and it is independent of the medium through which it travels. The frequency of electromagnetic wave can range from less than million hertz to the septillion hertz or higher, depending on the source. So, it has proven useful to view electromagnetic radiation as the propagation of collection of discrete packets of energy called photons or quanta, as proposed by Max Planck in 1900 in conjunction with its quantum theory. So in quantum theory, what Planck suggests, that each photon of frequency mu is considered to have an energy of E is equal to h mu, and we know that mu can be replaced by c lambda. So this E, which is represent the energy which electromagnetic wave contain, it depends on its wavelength, which is lambda. You can clearly see that the relation between energy and this wavelength, it is inversely proportional. Here the h, which is known as the Planck constant, whose value is 6.6 into 10 raised to minus 34 joule. This all theory we have already studied in physics. So energy of the photon, it means small e, is inversely proportional to the wavelength. So the smaller the wavelength, higher the energy. Higher the wavelength, smaller the energy that electromagnetic wave contain. The lambda, which is shorter the wavelength, radiation possesses large photon or energy. Okay. So based on the wavelength of the electromagnetic wave, it is classified in a number of waves. Here, this is a spectrum of electromagnetic wave. Here you can see that this is the range of 10 raised to 10 micron to the 10 raised to minus 9 micron of the range of wavelength. All the radio waves, TV waves, microwaves, thermal radiation, infrared, visible light, ultraviolet rays, X-rays, gamma rays, cosmic rays, these all are the electromagnetic waves. But they are classified based on the wavelength which they have, and due to that wavelength, the energy which electromagnetic wave consumes, the electromagnetic wave have, it is classified based on that wavelength. From the range of 10 raised to, here from the spectrum we can see that from the range of 10 raised to 10 micron to 10 raised to 5 micron, the electromagnetic wave known as the radio wave or TV wave. So as you can see that the wavelength of this radio wave and TV wave is from 10 raised to 5 to 10 raised to 10. So the wavelength is very high. So the energy contains by the radio waves or TV waves are very less. So it is not harmful for us. The wavelength of 10 raised to 2 to 10 raised to 5 is known as the microwaves, which is the kind of electromagnetic wave which is used in microwaves. From 10 raised to 2 to 10 raised to minus 1, it is thermal radiation, which is we are going to study in our heat transfer subject. From 10 raised to minus 1 to 10 raised to minus 4, nearly 10 raised to minus 2, which is known as the ultraviolet. From 10 raised to minus 2 to 10 raised to minus 5, that is X-rays. From nearly 10 raised to minus 4 to 10 raised to minus 7, it is known as the gamma rays, and 10 raised to minus 7 to 10 raised to minus 10, it is known as the cosmic rays. So here from the spectrum we can see that as the wavelength is going to decrease, the amount of energy, amount of photons contained by the electromagnetic waves becomes higher. So it will become harmful for the humans. So we can see that the gamma rays, cosmic rays and X-rays are the harmful for the humans. These are the waves which are produced by different methods, like TV and radio waves are producing by flow of alternating current through the electric conductors, we know. For the microwaves, there are special types of electron tubes such as klystron and magnetrons. For the production of X-ray kind of electromagnetic wave, there is a bombardment of metals with high energy electrons. For gamma rays, nuclear reaction produce gamma rays kind of electromagnetic wave. So the type of electromagnetic radiation. So the type of electromagnetic radiation that is importance to the heat transfer is the thermal radiation. This range from 10⁻² to nearly 10⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻ energy transition of molecules, atoms and electrons of the substance. Thermal radiation is continuously emitted by all matter whose temperature is above absolute zero. Here we can see that the plants, the walls, the peoples, the furniture, all these things whose temperature is above absolute zero, they are continuously emitting radiation. They are continuously emitting electromagnetic wave which possesses some amount of energy or some amount of photons, or we can say that packet of photons. What we call light is simply a visible portion of electromagnetic spectrum, that is lights between 0.4 we can see from this spectrum from 0.4 to 0.76 micron. This portion is known as the visible light, which we can see by our eyes. So this is the only range which can be visible by our eyes. The other electromagnetic wave we are not able to see this all waves by our eyes, because the range which our eye can see is only this range, which is known as the visible light. A body that emits some radiation in the visible range is called the light source. Of course, we know that the sun is obviously our primary light source. The electromagnetic radiation emitted by the sun is known as the solar radiation. In heat transfer studies, we are interested in the energy emitted by bodies because of the temperature only. Therefore, we will limit our consideration to thermal radiation, which we will simply call radiation. So, in our today's lecture, we have discussed how radiation mode of heat transfer is differ from the conduction and convection. In our conduction mode of heat transfer, we require medium. Conduction is generally occurred in a solid medium or between two systems which are in a physical contact with each other, and whenever there is a temperature difference between two systems. Convection mode of heat transfer will occur between the solid and the fluid, whenever there is a fluid in motion and there is a solid boundary, and whenever there is a temperature difference, the heat transfer takes place by the convection mode. So in a conduction and in convection there is a need of a medium, but radiation is a totally different from the conduction and convection. Electromagnetic wave is responsible for the radiation mode of heat transfer, and for the propagation of electromagnetic wave there is no need of any medium. It can propagate in medium as well as in a vacuum. Even in a vacuum it will propagate at the speed of light, which is a c. So electromagnetic wave is responsible for the radiation mode of heat transfer. So the question is, what is electromagnetic wave? So electromagnetic wave is a wave which is generated by the vibration, or we can say that motion of the particle, motion of the energetic particle, because whenever the atom which vibrate or make motion, it result in change in electric and magnetic field, and rapid change in electric and magnetic field will result in propagation of electromagnetic wave, and that electromagnetic wave contains photons, or we can say that contain energy. So different material at a different temperature emits electromagnetic wave of different wavelength, and according to that wavelength there is a huge spectrum from 10 to minus 10 to 10 to 10 micron, and according to that wavelength different kind of electromagnetic wave are classified. There are radio waves which have a huge wavelength but very less energy, then X-rays, then gamma rays, then visible range, then ultrasonic waves, then cosmic waves. But for the heat transfer our consideration is only thermal radiation or a visible light, and the radiation which emits by the body because of its temperature. So this is the introduction of radiation, how it differs from the conduction and convection. I hope you understand. Thank you so much. That's it for today.